Welcome, everyone. I'm very happy to be here at KubeCon and lovely weather in London. I want to talk about OpenStack. I usually start those presentations by trying to explain what OpenStack is and come up with the definition. But today I don't want to start with the definition. I want to end with the definition to change and start with a story, a sad story of lost glory and forgotten times. So the story starts in 2010 when Rackspace assembled a team of open source experts to work on open sourcing the next generation of their cloud infrastructure software. The team was assembled mostly from people coming out of Canonical and the team behind the Drizzle database at the time. At about the same time, a team at NASA with Eucalyptus, and they were trying to overcome a few scaling and performance issues. And they wanted to contribute back patches to the community edition of Eucalyptus to fix it. And they realized that they couldn't contribute those patches back to the open source edition of Eucalyptus because that would have jeopardized the business model of Eucalyptus around their community edition. So they wanted to basically keep scalability as a feature for their enterprise edition. So they started working on their own stuff as well. And the two projects converged and formed, oops, is this working? The two projects converged, and that's where OpenStack was created. This is a picture of our first public design summit in a room in Texas. That's all there was to it, small group. There aren't so many people that are still around in that picture. It's a fun one. So by 2011, the world got very excited. We had a design summit in Santa Clara in April, and hype was everywhere. I mean, really everywhere. You had venture capitalists trolling the corridors, throwing money at anyone that could vaguely articulate a product pitch. And it was really good times, easy money, fast cars, drugs. Good times. Well, OpenStack was supposedly production ready and carrier grade. This was actually not working at all. It's really fun. By 2012, large companies wanting to be in that fun game. The problem is they didn't want to contribute if Rackspace was owning the project and could change the governance at any time. So there was a lot of external pressure and internal pressure to move the projects to an independent body that would own the project from there on. And that's when the OpenStack Foundation was created. That created a surge in participation and popularity for OpenStack. And in 2013, we are at the top of our game. It's like craziness. The first actually production-ready release, Grizzly release, came out that year. So this is 2014. We still have a lot of people coming to our summits. This is a picture of the summit we held in Paris, where there's like 5,000 people in that room. But something changed. There is no excitement anywhere. People are here for business, making money. Hype is gone. So what happened? Well, this happened. Containers. Thanks to Docker for making them accessible to everyone. The container analogy is extremely photogenic, so it makes for great presentation slides too. So yeah, the containers was the next exciting thing. The hype had moved away. Our 3 years of glory were gone. No more hype. No more crazy press watching our every move. No more sensationalist clickbait headlines predicting our imminent demise. Oh, don't get me wrong. I think it's a great thing that hype is gone. The hype means more sanity, more long-term thinking, less short-term thinking. And personally, I'm interested open collaboration spaces, and venture capitalists and startup money is not playing that great with an open collaboration system because they kind of need to differentiate. They had to differentiate really, really fast, so they keep a lot of secret sauce out of the open collaboration. So I think the fact that hype is gone is not a bad thing for OpenStack. But here we are in 2015, and we are talking about containers in OpenStack summits, or I'm here to speak about OpenStack in a container-oriented conference. Does it mean we lost? Does it mean we are past? Does it mean we've been made technically irrelevant by Docker, Kubernetes, Mesos, and all the cool stuff? Does it mean that more than the hype is gone? Well, not exactly. So Kubernetes, Mesos, Docker, they're looking into the following problem. You're an application developer. You have an application and you want to push it on servers to run it. Traditionally, you would go through a series of steps to do that. The first step is packaging. So in the pre-Docker world, you would use like jar files or Debian packages or your own unicorn format to package your application, their dependencies, etc., in a way that you can actually deploy them. Second step is deployment. Here you would use configuration management, continuous integration systems, or some kind of magic unicorn thing to deploy your workloads, your packages to the servers that would end up running them. Now, the introduction of VMs did not really change much to that game. It just changes the concept of servers. It just abstracts the concept of server from the underlying hardware that's running them. You would end up pushing your workload to a VM rather than a bare metal machine, but it's the same game. So now Docker changes those steps, those tools, those formats, and lets you package and help deploy your application as lightweight containers. So it's like a one-stop shop, single tool that you can use to solve most of those problems. Then you still end up running that on Docker-enabled infrastructure, bare metal machines, or VMs running Docker hosts. But otherwise, it's a great simplification. But then Docker is more than just a packaging thing. It also enables you to rethink your application in a microservice type architecture. So lots of small, lightweight containers talking to each other and having very, very precise roles. That quickly created the need for more advanced deployment tools, orchestration tools, what we call orchestration engines, and that's what Kubernetes is designed to solve. So you package your application using Docker containers, then you describe the relationships between those containers, the rules that are used to deploy them in Kubernetes, which then pushes them for running on a Kubernetes cluster, which ends up running on bare metal servers with Docker-enabled hosts or on virtual machines below there. Now, if you take Mesos, it's a slightly different approach. The data center operating system is about creating a cluster of Mesos machines where you can schedule tasks, as if it was like a single machine. It was a slightly different approach from the Docker approach, but they saw the wave coming and they adapted so that you can describe tasks as containers and schedule them on a Mesos cluster. So it's essentially an alternative to Kubernetes to schedule your container workloads to the servers that will end up running them. But that's just like two options, right? In any complex environment, it's more likely that you would end up with something like this. So users wanting to deploy containers directly, Docker users wanting to deploy Docker containers through Kubernetes cluster, another wanting to go through a Mesos cluster, some people just wanting to use Mesos directly for what it was designed for, and you will still have the unicorn guy who just wants a virtual machine or a VM to deploy stuff. So you can also look at the problem from the opposite direction. You're an infrastructure provider and you want to deploy something on your rack of machines to solve all the needs for all those different users. And that's what OpenStack is designed to solve, something you can deploy on top of your bare metal machines that help you serve the infrastructure needs of all those different users. So OpenStack is an open source project licensed under Apache 2. It's an open collaboration. We have thousands of developers, hundreds of organizations involved. The mission of that community is to provide infrastructure as a service in the large sense of the word. It's a collection of projects which provide APIs that you can programmatically address you can use to programmatically get infrastructure resources out of your hardware resources. All those projects are tied together with common authentication, so you can use you can generate tokens and use them across all those projects. And finally, an important point is that it's not really a product, like something you can take off the shelf and just deploy, and you have OpenStack. It's more like a framework, lots of drivers, lots of options, lots of optional pieces. So it's more something you can use to build an infrastructure provider rather than just pick So let's look at a few ways you can leverage OpenStack to. It's not working well. Well, let's try another one. And now I have. Okay. So let's see a few ways you can use OpenStack to solve infrastructure needs. The simplest way, you want to have a you want to have a VM to deploy your unicorn thing to. Then you would call OpenStack Nova, which would provision a virtual machine using KVM or Xen. We have a piece called Neutron, which will provide network connectivity to that VM. If you want block storage resources, you will leverage a project called Cinder. And Keystone is the common authentication system that will hand out tokens, authentication tokens, for everything to just work. So that's pretty simple. That's the basic thing. Now, if you want a bare metal server, Nova can leverage the Ironic project to actually provision your system on a bare metal machine instead of a VM. It's a lot slower than getting a VM, obviously, but otherwise it's the same API you can use to request a bare metal machine and not pay the virtualization tax if you're not interested in that. Glance is our disk image catalog, and if you, it's the system images that you will end up deploying on those VMs or those bare metal machines. Now, if the system you end up deploying on them is a Docker-enabled host, say like a CoreOS image, then the bare metal machine or the VM you requested out of the infrastructure will let you directly run Docker containers. That's pretty simple. But what about Kubernetes? So Kubernetes, you have different approaches. You can request a set of bare metal machines or VMs from Nova and then deploy Kubernetes yourself on top of it. That's one way of doing it. You can also leverage two other projects we have. We have a project called Murano, which lets you deploy applications on top of OpenStack resources that you own. So you would get a number of bare metal machines from Nova, and then Murano will help you deploy Kubernetes on top of it. It's more like a Kubernetes install as a service type thing. It's not just about Kubernetes. It can deploy other application stacks, but it has a formula for deploying Kubernetes. So that's another way of doing it. Then we have the Magnum project. The Magnum project is more like a Kubernetes as a service type thing. You have an API, which is actually container orchestration engine agnostic, and you can request a Kubernetes cluster. You don't really own the VMs or the bare metal machines that will end up running your cluster. You just want to have a cluster of a Kubernetes cluster out of the API call you make. So you just give me a Kubernetes cluster, give me a Mesos cluster, give me a Docker Swarm cluster, and Magnum will spawn up the bare metal machines or VMs that are necessary and deploy Kubernetes or Mesos or Docker Swarm on top of it. So that shows that Kubernetes, Mesos, or Docker, they're not really replacing OpenStack. They're answering a different question. If you take the application developer point of view, then what you want is a tool to deploy your workloads. If you want to take the infrastructure provider view, what you want is something you can deploy on top of your machines to help solve those users. So they're actually complementary. And that's something that Google understood very well when they joined the OpenStack Foundation last year. They wanted to ensure that we would have tight integration between Kubernetes and OpenStack so that it's fully supported. We've seen the first results of this collaboration. We have Cinder volume support inside Kubernetes now. We have support for Keystone tokens in Kubernetes. And we have also support for deploying Kubernetes on top of OpenStack, obviously, in Kubernetes now. So that's the result of the collaboration between the two communities. But so generally at this stage, you're just asking yourself, why? Why would I go through the hassle of deploying this OpenStack thing, which is so complex? I mean, my needs are pretty simple. I just want a Kubernetes cluster. Why on earth would I go through installing OpenStack to do that, right? Well, it's not for everyone. But there are a few benefits of using OpenStack to do that. The first benefit is that it gives you options. You might just need a Kubernetes cluster today, but maybe tomorrow you will want a Mesos cluster, or you will want a VM, or you will want a Docker-enabled host to do stuff. If you're 100% sure everything you'll ever need is a Kubernetes cluster, then by all means don't touch OpenStack at all. But if what you want as an infrastructure provider is to make sure that you support different infrastructure use cases, and what you want is to solve other problems, open options to your developers, then using OpenStack is actually one option. The second benefit of using OpenStack is multi-tenancy. So the ability to properly isolate and account for the resources that are consumed by various different actors in your infrastructure system. OpenStack has built-in support for multi-tenancy, so you would not end up with like containers coming out of owned by different people or different groups of people end up running on the same bare metal machine. So that gives you that. It's obviously something you really want to have if you're a public cloud infrastructure provider, because you don't really want to have shared resources or test how isolated your containers actually are. With multiple tenants owning the same bare metal machine. But it's also interesting if you're a company with large infrastructure and want to account and isolate the resources that are consumed by various departments inside your own company. Another benefit is the toolkit. OpenStack doesn't just provide raw infrastructure resources like VMs or bare metal machines or Kubernetes clusters. It also provides you higher level building blocks for your applications. So we have, if you want to store data, you could leverage Swift project, which does object storage. If you want databases, you've seen Kelsey's keynote this morning saying, well, you might want to have something that is actually aware of how to scale a database rather than just hope that it will scale. Well, the Trove project is database as a service. So you just get the database and let Trove scale it for you rather than do it yourself. If you want, I don't know, a Hadoop cluster for one day, then the Sahara project can help you get that Hadoop cluster on top of the OpenStack resources, DNS resources, designate messaging as a service, et cetera, et cetera. So it gives you more than just raw infrastructure resources. It also gives you higher level building blocks that are potentially useful for your applications as well. Another reason why you might consider OpenStack in a Kubernetes or Docker situation is if you own very expensive networking hardware and you kind of want to make use of all its capabilities. We have a project called Courier, which bridges between container networking and Neutron API. Neutron has plenty of specific plugins to deliver the capabilities and performance and features of these expensive hardware, expensive networking gear. And so if you want to kind of reuse that, Courier will let you bridge between container networking and Neutron networking. So that's one other potential reasons. The last benefit of using OpenStack is that it's future-proof. OpenStack is not just a finite set of projects. It's more like a community with a mission of giving you infrastructure as a service in a large sense. So whatever comes next will act as an integration engine and include it in OpenStack. I mean, originally it was more about VMs, more about providing a classic cloud experience. Then we saw that bare metal machines were interesting to get as well, and so we created the Ironic project. Then Kubernetes, Docker, and all those things came out, and we adapted to let OpenStack provide those resources under the shape that you actually want them. So whatever comes next will be there to integrate it as well. Is it unikernels, whatever, we'll probably have a project to cover it. So it's about serving the needs of the users of today, but also the needs of the users of tomorrow. So it's like a future-proof solution. If you're an infrastructure provider, what you want is install something that will stand the test of time rather than just respond to what you need today. How are we doing with time? Plenty? OK. So we changed the governance of OpenStack over the last 2 years to adapt to this new view, more community-centric view, mission-centric view than product-centric view. It used to be what we called the integrated release, which was really a finite set of projects with a very narrow cloud-centric definition. And we changed that because that view was way too narrow to enable innovation and new ways of using infrastructure. And so we changed that. And now if a project is aligned with the mission of OpenStack of helping providing infrastructure, solving the infrastructure needs of the users, and it is developed under the open collaboration, open development practices that we've set up, then yes, you are part of the community. You are part of us. You are part of the same goal, and you should be an OpenStack project. So we changed the question from is this OpenStack to are you OpenStack? And that's what enables this integration engine shift. Now we are more like a community around a common goal rather than a set of projects, very precise set of projects. So that brings us back to the initial question, the definition. What's OpenStack? And so I found a definition. I couldn't make one up. It's too difficult. So I will just read it. OpenStack is not a cloud. It's not a project. It's not a product. It's not a virtualization system or an API or a user interface or a set of standards. OpenStack is all those things and more. It is a framework for doing IT infrastructure, all IT infrastructure, in as interchangeable and interoperable a way as we're ever likely to know how. Thank you.
So I did see a lot of hands go up saying that you were running OpenStack. So put those hands back up. How many of you are running Kubernetes on OpenStack today?
Oh.
Still a good chunk. So do you have any questions from those deployments of Kubernetes and OpenStack?
Are you running using Murano or Magnum or directly yourself?
Via Terraform.
Right.
So there's a
Yeah, that would be install yourself. Yeah.
quite a few gaps in Terraform for OpenStack today.
Other folks who are running OpenStack?
Yeah, I just wanted to add that honestly, I've tried both Murano, I've tried Magnum. Vagrant is much easier.
Yeah, I mean, if the Kubernetes community does its job right, the first option where you just deploy it yourself should be the one that wins in the end. I mean, the whole Murano versus Magnum thing, I don't really buy into the container orchestration engine as a service approach either. I think if Kubernetes installation is nailed out, then it should be easy to just deploy it on top of resources you get out of OpenStack and be done with it. I'm not sure we actually need those. But it's good to have experiments. It's good to see if one of them will just take out the world, but I wouldn't place my money on it. Well, we don't have incubation anymore, so they're both official projects, and Murano is more than just Kubernetes, so it's good to have Kubernetes as one of the things it can deploy. The Magnum approach is interesting because you get that pre-baked Kubernetes cluster, but then it's not that difficult to deploy your own Kubernetes thing either. So,
Are there any other questions for Thierry? Well, we've got him here.
so I'll be at the OpenStack booth after lunch if you want to meet me there too.
Just quick, I'm not quite sure I understood these different projects. For a Nova host, you configure the hypervisor that host is going to use. Is there a kind of Docker hypervisor just for Nova?
Yeah, there is. So we have ways of provisioning containers, like fat containers, as if they were a virtual machine. So you can leverage the Nova Docker pseudo hypervisor to actually give you a fat container that runs dual OS. I wouldn't recommend using that though. Mostly because I think you get the worst of both worlds. You get that fat container that is not necessarily enabling you this lightweight containers approach. You're not rethinking your application as all those with this microservice architecture, or taking benefit of the 10 years of experience that Google has and all those best practices around running containers in pods. I think it's pretty great, the work that they've been doing, and I think it's the way you should think about your applications. So if you just have containers, you accept the drawbacks of between the isolation, the security around containers, and you don't have any of the benefits of the containers on the other hand. It feels like you get the worst of both worlds running fat containers, but the option is there. It's just that I'm not a fan of it.
Why do you keep saying fat? What's fat?
If you're running a full OS inside the, so if you provision a container, if you are using the pseudo container hypervisor to get out of Nova container, right? Then you deploy a disk image on top of it. That's a complete system. So you just don't package. You end up running a full image of an operating system.
I don't understand. It's not another kernel. It's still container. It's leveraging the host's kernel.
Yeah, but if you end up having all the system image inside the container, you're not reusing as much. You end up with containers that will run a lot of.
Docker driver can run any image, any Docker image.
So you mean you can use the Nova Docker to run a smaller image that would end up sharing enough with the operating system that you would not end up like a full system copy, right? Well, that's true, but then you end up still with an object that looks like a VM, right? You're not taking advantage
Nova
of.
thinks of it as a VM, yes. And in particular, so Nova can't create pods. Nova can't put two containers together in the same network namespace like Kubernetes does. And indeed, that is missing. But the container itself is not necessarily fat.
Right. So yeah, I see your point. My point with fat containers is more a question of not leveraging the new features that Kubernetes and other container orchestration engines
so it's
are.
a Nova API, not a container
Right.
API.
And so I think if you end up scheduling your workloads on containers instead of rethinking your application with container orchestration engines, then I think you lose something. But as I said, I don't have the universal truth here, and just feels like you end up with the drawbacks of running containers without much of the benefits of running them.
So,
But
Terry, there's
yeah,
one more question.
sure.
I have a question. Are there reference architectures for using Kubernetes and Magnum, using Kubernetes and Murano available?
Yeah, we have the so on the booth we have the white paper that describes the various reference architectures around that. I think it doesn't mention the Nova Docker hypervisor, especially because it's not mainline. So it's something that is not living in the mainline code, but the other options are pretty well described there. So just come and pick it up. Sure.
What are your thoughts on the unification of service discovery between OpenStack and container frameworks, so that we basically have a way of spinning up a Nova instance that is discoverable by containers easily, right? I mean, designate does kind of this job, but I guess it can be done more easily.
Yeah, I think we should work more on bridging the way containers discover things and use things. So the Courier project, which I described as a networking bridge, actually looking into bridging other features like service discovery and storage. They just applied like 2 days ago to change their mission beyond networking. So so they would exhibit higher level constructs of OpenStack, like storage or backup services, and make them usable with the third-party API and Kubernetes and other entry points. So I'm confident that we'll bridge between the two communities so that things like service discovery can be more integrated. But today it's more two worlds that are like just judging each other, not really. There is not a lot of cross collaboration between the communities. One of the reasons I'm here is to look into those integration points and see how we can make the OpenStack experience for a Kubernetes user more seamless. Currently, it's more like it's about the same thing if you run Kubernetes on top of Amazon and Kubernetes on top of OpenStack. There is no, we don't take the benefit of being able to integrate deeper. I think it's sad, and hope we'll work on that direction.
Are there any other questions?
Okay, again, why do you not think that it's interesting to offer Kubernetes as a service?
So what I think is it's just because it's more difficult than it should be to deploy Kubernetes. I mean, so you end up having two APIs. You have one API to provision your resources and one API to use those resources that are using different tokens. And so my view on it.
I understand what you mean by that.
So I think Kubernetes will come to a point where it would provide this cluster API directly. So I don't think we should be in the business of having this specific API to provision clusters when Kubernetes is growing features to just request more resources out of the infrastructure provider. I'm not sure that's the right place of doing it. I think if the integration between the two systems is done, you will be able to use the Kubernetes API, put some OpenStack credentials in there, and then whenever you need to scale up that Kubernetes cluster, it will request more resources out of the system. I don't think there is value in the container orchestration engine agnostic API. I'm not sure people want to use the same API to provision a Mesos cluster and a Kubernetes cluster, basically. So I'm questioning the value add, but then I know that a lot of people are looking into that, are looking into deploying Magnum. So I'm happy to be proven wrong. I'm just not convinced it's the right point where to provide a provisioning API, basically. I think it belongs to Kubernetes in the end. I don't think we can convince Kubernetes users, basically, to use something else than the Kubernetes API.
Use something else and the Kubernetes API.
Use the Magnum API in addition to the Kubernetes API. If Kubernetes grows those cluster scaling features, which they're working on, then what would this crowd look into the Magnum API? They don't need to. And those are the users. So I think it's more important to make sure that it's easy for Kubernetes to scale up with OpenStack resources, rather than provide a container orchestration agnostic API to provision base of clusters, basically.
Maybe I misinterpreted yours. Get backwards what you meant. So you're disfavoring Magnum. You think it's a bad idea to offer a bunch of independent bays.
I think the concept of having an API to provision a bay is not the right integration point. I think this will be in the Kubernetes API tomorrow or the next year, right?
One of the upcoming releases.
Right. And so where is the value for Magnum users then? Because in the end, the application developers, they will run the Kubernetes API anyway. They have to it's
they will use the API. They probably won't run the API server.
Sure. Totally. But they will use the Kubernetes API to schedule their application on the workloads to run. And so the value proposal of Magnum is that, no, you should also learn the Magnum API to actually provision your base. And I think there is more value in deep integration within Kubernetes, so that Kubernetes can grow can install and grow a cluster on top of OpenStack resources by just putting a few credentials in a config file. Because then it's natural to use OpenStack resources out of Kubernetes. You just have to learn the Kubernetes API. You just configure OpenStack as the infrastructure provider for the Kubernetes cluster, and you're done. So how would you go through to those users and explain to them, well, no, for the provisioning part, you want to have the Magnum API. I'm happy to be proven wrong again on the Magnum thing.
I see what you're saying. Thank you.
Sorry, I'm a bit confused. Confusing.
One more question.
Sorry.
You have been talking about running Kubernetes on OpenStack, but I would be interested to run OpenStack on Kubernetes.
So that's another one. So we're also working on trying to package OpenStack in containers so that you can actually deploy. Well, and then you just end up with an inception type thing. But there are some challenges around networking, around a few pieces that are not really happy to run into containers right now. But there are lots of people working on that, because it would solve a lot of the complexity of installation that we have in OpenStack if we could deploy it with a set of containers. And it ties into the container story quite well, because we have all those different small services, API services that are talking to each other. It's not impossible. It's just that the thing we do are so low level in OpenStack for some of the features we are using, that some of the workloads are not happy running inside a container. You can totally run like Keystone, containerized. It's just happy to do that. Nova is more difficult, obviously. Neutron, sorry?
Which workloads are not happy about being in containers?
So we have Neutron, Ironic. I think Neutron is mostly covered now. So the project is called Cola, and it's like an ongoing effort to package OpenStack into containers.
Yeah, because I have several Cola VMs, and all what I regard essential OpenStack services are running in containers.
So what could you?
OVS doesn't contain fully containerized.
So yeah, it's only a few. I mean, there might be like a set of options you can pick to support to run Neutron in. I think there is one of the drivers. You should know that. Of all people.
Doesn't matter.
I know. So I know Ironic is not running. Happy to run under.
Yeah,
I know Cinder has problems as well because it's addressing block storage directly. I know they're still struggling with like supporting all the different options we have in Neutron. But we'll get there. It's just a question of kernel capabilities. I think some of the things only work with very recent kernels. So it's an ongoing work, but I think it's a great. I mean, I really believe that it will solve a lot of the OpenStack deployment problems if we can describe an OpenStack installation and deploying on top of Kubernetes cluster that will run on bare metal.